continue with the next sessions from Emrah. Emrah is, well, it could be from the Netherlands, it could be from Turkey, it could be from anywhere. He lives everywhere.
Yeah,
I mean,
we are working remote, so
yes, so
we are location independent.
Yeah, so it's a bit like I think in the cloud with all these containers and so on. So everywhere. Okay, Emre.
Thank you. Hello, welcome everyone. Can you hear me? Okay, great. In this presentation, we are going to talk about the idea of running your PostgreSQL databases on a Kubernetes cluster. Before I start the presentation, can we do a small survey, please? Is there anyone who's running their production Postgres on Kubernetes? Any production on Kubernetes? 1, 2? Okay, great, thank you. It's almost similar everywhere. Today, when you start a new project and develop a new application, the mainstream choice is to pack your application within a container and deploy it on a platform like Kubernetes. It will be fair to say that this has become the norm now. However, when it comes to Postgres itself, we see that most of the companies or organizations still rely on the virtual Linux servers. So it's almost similar everywhere. Let's say you are at work, you are sitting at a table with other colleagues, and your CTO suddenly brings up the subject and says, hey, I have heard that you can run Postgres on Kubernetes, and asks, why don't we use it? How are you going to answer his question? Well, you have two options. You can object to the idea and say that, no, we shouldn't be using Postgres on Kubernetes. But then why? What's your excuse? Your CTO is actually right. There are others already running Postgres on Kubernetes. Do you really have strong arguments against its usage? Your other choice is that you can welcome the idea of Postgres on Kubernetes and say that, hey, okay, we can try. But again, why? Your Postgres is running on virtual servers. They are performant. They are highly available. You are simply happy with it. Why would you give up all that infrastructure and migrate to Kubernetes? Well, there is no direct answer to that. And within this presentation, we are going to try to answer this question. And we are going to try to decide whether it's worth migrating your Postgres onto Kubernetes. Let me briefly talk about myself. I'm Emrah. Nice to meet you, first of all. I'm a database administrator. I've been working for the last 20 years. At the moment, I am working in European Patent Office, known as the EPO. And I have a special interest in Linux internals and database internals. During the work, if I can find free time, I like to read about the Linux internals and do some kernel hacking. We said that we were going to try to decide whether it's worth migrating to Kubernetes or not. In order to give a healthy decision, we first need to have a good grasp of what containers and Kubernetes are. These technologies are popular today, but they did not appear out of nowhere. So first, let's see how we ended up with containers. This timeline shows the virtualization, the trends in the virtualization technologies. In the good old days, life was simple. Everybody used bare metal servers. By 1999, we started hearing about the virtual workstations and virtual servers. Large vendors, which we still use today, have entered the market with their own hypervisor products. A hypervisor is the actual software that partitions your hardware into virtual machines. And by 2013, we started hearing about the containers and Docker, and finally, Kubernetes. At the moment, we are living in this containers era. Containers offer us an alternative to virtual machines, so it is possible to pack your Postgres processes inside a container and run it that way. Let's see what it looks like. This is the conceptual diagram of a server with containers running on it. At the bottom, we have the hardware layer. Your CPU, RAM, and hard disk are your physical resources. On top of that, you have directly the operating system layer. There is no hypervisor, there is no virtual machines, directly in the operating system layer. However, we see that relevant processes are grouped into what we call a container. For example, this blue one is the database container, and all the Postgres processes are grouped into that. This yellow one is the web container. The HTTP daemons, which are actually Apache web server, are grouped into that container. And the last one is the printing container, where the cups daemon is running. Cups daemon is the process of the printing server. So it is possible that you will share the server with totally irrelevant processes. That's how the containers work. We've seen what a server with containers look like. Now we will delve deeper and explore the technologies behind those containers. In its most simplistic form, a container is just a group of processes. That's it, nothing fancy. Containers equals a group of processes. All the functionalities you observe in a container are actually implemented using Linux kernel features. For example, in Linux kernel, we have a feature named namespaces. These namespaces allow you to isolate a group of processes from others. For example, processes within a container will think that they are the only process in that operating system. They will not be able to see the other processes or interact with them. It is also possible that processes within a container will have its own distinct host name and distinct IP addresses. So the processes will think that they are running on a dedicated server with its own distinct host name and IP addresses. Another isolation is that within your container, you can mount some directories. However, those directories will only be visible to you. The other processes won't see your mount points. These are all implemented using this namespace feature. Another feature we use in containers is the control groups, or shortly called C groups. With these control groups, you can limit how much CPU, memory, network bandwidth, or disk bandwidth a container can use. For example, you can say that, hey, I want this container to use maximum 2 GB of RAM. So what happens if that container tries to use more than 2 GB? Then the Linux out-of-memory killer will kick in and will start killing processes within your container to keep your usage under 2 GB. On the opposite, you can instruct the kernel to try to guarantee a minimum amount of RAM. For example, you can say that, hey, I want this container to have minimum 1 GB of RAM. Let's say your container tries to allocate 1 GB, but there is not enough memory on that server. What happens now is that, again, the out-of-memory killer will kick in, but this time it will start killing the other processes in the operating system to make room for you. This is how the Linux kernel tries to guarantee the minimum resource usage for your containers. And the last feature is the pivot root. Pivot root is actually a Linux system call. You know, we have the root directory at top, and it is mounted somewhere. With this pivot root call, your container will think that it is in the top root, in the top directory. However, that mount point will actually point to some subfolders. This way, it will not be able to access the files in the upper directories. Using this feature, you are actually restricting access to the files in the upper directories. The namespace and control group features actually date back to 2006. However, we didn't use them much because manually creating the containers were no easy task. Simply, they were not practical. So we needed an easier way. In 2013, the Docker project was announced. Its logo is a whale with carrying containers on its back. This Docker project provides you a framework where you can build, run, and administer your own containers using simple commands. This project greatly simplified working with containers, and after this one, the containerization technologies gained popularity and adopted by many. And we have the Docker Hub. The Docker Hub is very much like a package manager repository. Instead of packages, we have the Docker images there. Let me briefly explain what a Docker image is. An image is simply an archive, a tarball of files. That's it. For example, if I want to create a Postgres image for Docker, I have to copy all the Postgres binaries and its dependencies into an archive file, and that would be my Docker image for Postgres. In this Docker Hub, you can download the images created by others, or you can upload your own images. We have the Postgres community for Docker Hub. This community, these folks built Docker images for all the major and minor versions of Postgres. They also create images for different CPU architectures like Intel, ARM, and PowerPC. The images created by these folks have been downloaded for more than 1 billion. So these images are actually more popular than you think. Docker with Postgres would be a great choice to use in your local development and test environment. Even if you have no DBA knowledge, you can spin up a Postgres instance using just a single line of Docker command. Actually, the development teams use this a lot. We said that Docker is a great choice to use in your local development and test environment. However, when you want to run in a production environment, you would need a more advanced solution. And the container orchestrators are the advanced solution you would need in a professional environment. So, what should we expect from an orchestrator? First is the horizontal scalability. I should not be running my containers on a single server, but instead I should be running them on a cluster of servers. And I should be able to add more servers to my cluster if needed for more computing power. This is horizontal scalability. And the high availability is that if one of the servers crashes in my cluster, the containers which were running on that failed node should be restarted on the other remaining nodes automatically. The orchestrator should handle this automatically, so I should not have to manually intervene. And the final part is load balancing. My orchestrator should distribute the containers evenly on my cluster, and I should not have to worry about where to place them. This is something we would expect from the orchestrator. Today, there are 3 popular orchestrators you can use: Kubernetes, Docker Swarm, and Red Hat OpenShift. So when you see Kubernetes, know that it's just a container orchestrator software. This is what a Kubernetes cluster looks like. In this example, we have 3 physical servers, and these servers are connected to each other using a network link. The containers are distributed among these servers, and Kubernetes is the actual orchestrator software that manages this entire environment. Now we have seen what a Kubernetes cluster looks like, and now we are going to see how we can run Postgres on top of that. Kubernetes is a generic platform. For Kubernetes, everything is just a process. It is unaware of what is running inside those containers. This lack of knowledge, however, can be compensated by what we call an operator. An operator is actually a software that you develop yourself to manage the applications within the containers. So in a simplistic form, we can say that a Postgres operator is actually a software that you develop to make Kubernetes Postgres aware. Because normally Postgres is a generic platform. It cannot know what Postgres is. With the use of these operators, you actually make the Kubernetes Postgres aware. Today, there are 3 popular Postgres operator projects you can use. They are both open source. The Zalando Postgres operator, Cloud Native PG, and Crunchy Data. In this presentation, I am going to show an example with the Zalando operator. This operator, the Zalando operator, was developed in Go programming language. And within this project, they provide you a Docker image, which is based on Ubuntu operating system. And on top of that Ubuntu, we have Postgres and Patroni bundled together. Now we are going to see a complete working running example with Zalando operator. The first step in creating a Postgres cluster on Kubernetes is to define it. Because the Postgres operator is declarative, which means that we have to tell the operator what kind of a database we want. And second step is to define this operator in what we call a YAML file. A YAML file is just a type of configuration file format. In a professional environment, you will want to store this YAML file in a code repository like GitLab. This way, all your Postgres infrastructure will be defined using those YAML files, and they will be stored on a code repository. This is called infrastructure as a code. Okay, this is a sample YAML file which the Zalando operator recognizes. I will briefly review what these lines mean. In this line, I tell the operator that I want to use this specific Docker image, so the operator will connect to that URL and download the image and start it. Here, I tell the operator that I want a Patroni cluster with 3 members. Here, I tell the operator that I want it to create a Postgres user named my DBA user and give him the super user privileges. Here, I tell the operator that I want a user named HR user and give him the login privileges. And here, I tell the operator to create a database named HRDB for me, and that DB should be owned by the HR user. This is the second part of the YAML file. Here, I tell the operator that my cluster should be using the major version 16. And here, I define the parameters. So the operator will connect to Patroni and set these PostgreSQL parameters for me. They are the regular Postgres parameters that you know. Here, I tell the operator to create a volume with 20 gigabyte in size. This will be the my actual disk size. Here, I define the minimum resource requirements for my container. And here, I define the upper limit of my container. So my database container will be able to use maximum 2 CPUs and 4 gigabytes in this example. Okay, so we have defined our cluster in a YAML file. Now the next step is to deploy it to Kubernetes. In order to do that, you have to build what we call a pipeline. And in order to build a pipeline, you have to use a CI/CD tool like Argo CD. CI stands for continuous integration, and CD stands for continuous delivery or continuous deployment. Okay, this is what a Postgres pipeline looks like. Here in my local environment, I prepare my YAML file. I define my database, my Postgres database cluster, and I commit it to my Git repository like GitLab. And here we have the CI/CD tool like Argo CD. This CI/CD tool automatically fetches this YAML file and pushes it to Kubernetes. Once my YAML file ends up in Kubernetes, this Postgres operator will automatically fetch that, and it will create the Patroni cluster for me. For example, for this example, I wanted a Patroni cluster with 3 members. So the Patroni operator created 3 containers and distributed it on my Kubernetes cluster. These operators support backup and restore functionalities. For Zalando, it will store your backups in what we call S3 buckets. S3 stands for Simple Storage Service, which is actually implemented by Amazon Web Services. However, it has become a protocol now. Your buckets can be either your on-prem systems or on cloud. Both is supported. The Zalando operator will take nightly backups using PgDay Backup. And as the archive and restore command, it uses volg. If you want, it can also take logical backups using pgdump, and it will store them in S3 buckets. The Postgres operator also supports standby clusters, Patroni standby clusters as a disaster recovery solution. Now I am going to show an example of a complete disaster recovery solution that you can implement using this operator. Here in the left, we have our primary Kubernetes cluster. And on the right, we have our standby Kubernetes cluster, secondary cluster. You have better place your secondary Kubernetes cluster in a disaster recovery site, probably in a different data center. On the left, we have our primary Patroni cluster, where our primary workload is running. And on the right, we have a standby Patroni cluster, and is that standby cluster running on the secondary cluster. The primary Patroni cluster will upload its backup files and WAL files in a S3 bucket. And this standby Patroni cluster will automatically fetch the backup files and WAL files and replace them. So this is how it will stay in sync with your primary systems. Okay, now we are going to see the monitoring and observability using the Postgres operator. The Postgres operator doesn't offer you any observability or monitoring product, but instead you use your own product monitoring tools. For example, Prometheus. However, you need to deploy your monitoring agent as a container within the database itself. It is called a sidecar container. On Kubernetes, we have a unit named pod. Within a pod, it is possible to host multiple containers, and they live side by side and interact with each other. For Prometheus, we have the Prometheus Postgres exporter. It's a public project, open source project. So you can actually deploy it as a sidecar container with your Postgres operator. The Postgres operator will inject that container within the pod. I am going to show an example. On the right side, we have what we call the Postgres pod. Within this pod, I have my Postgres container, where my Postgres is running. At the bottom, I have the Prometheus Postgres exporter container, so they live side by side. The statistics are stored in the database naturally. This Prometheus exporter connects to my database and fetches the statistics. And I have here a Prometheus server. This Prometheus server will connect to the exporter and scrape the metrics and store them on itself. On the Prometheus server, we have a timescale database. On this Prometheus server, you can define your own thresholds and alerts. and you can push those alerts to your DBA team. Similarly, you can also install a Grafana server, and this Grafana server can display your dashboards using those metrics. One thing to note is that both the Prometheus server, the Grafana server, are just another containers running on Kubernetes. So you don't have to depend on an external resources. All these can be implemented on Kubernetes. Okay, so we have seen what a Postgres on Kubernetes looks like. Now the final question. Should you be migrating your Postgres onto Kubernetes or not? Let's try to answer that. We really love Postgres on Kubernetes, and we have reasons for that. The first is to self-healing capabilities. Both Kubernetes and both the Postgres operator has some self-healing capabilities. In case of a failure, they will recover themselves automatically. So you won't have to manually intervene. For example, if your container dies, which means your processes has died, Kubernetes will automatically restart that. And using these operators, you can actually give a database as a service within your organizations. Let's say you have development teams, and even if they have no DBA knowledge, they can spin up a complete Patroni cluster with high availability using just a regular YAML files. They won't need to depend on a DBA team for that, and that's a great feature. And the last reason to love Postgres on Kubernetes is that you can actually offload some of your DBA tasks to the operator. For example, let's say you want to do a major version upgrade. All you have to do is change the setting in your YAML file from, for example, 16 to 17 and deploy it to Kubernetes. The operator will automatically capture this change and start an automatic major version upgrade on your behalf. That's all. All these features are declarative. So I don't manually upgrade my server manually, but instead I tell the operator that I want to upgrade it. There are also other tasks that you can offload to the operator. For example, point-in-time recovery or cloning of an existing cluster. They are all done in a declarative fashion. For example, I prepare a YAML file. I say that I want to do a point-in-time recovery. I set my target timeline in the YAML file, and the operator will automatically start a PTI for me. Okay, we said that we love Postgres on Kubernetes, but it's not always rainbow and sunshines. Now we are going to talk about the other side of the coin. We also have reasons to dislike Postgres on Kubernetes. If you decide to run your Postgres on Kubernetes, you will see that actually you will face more frequent switchovers than usual. With the switchovers, I mean the Patroni switchovers. And there are reasons for that. First, the Kubernetes maintenance. Every 3 or 4 months, a new version of Kubernetes itself is released, and your Kubernetes administrators will want to upgrade to that latest version. These upgrades are done in a rolling session. It means that one can be done in a rolling fashion, which means that one server at a time. However, during that upgrade, your leader node will have to switch over to a follower node. That's inevitable. And you will face that every 3 or 4 months. Okay, that's the most nasty feature, the out-of-memory killer and the node evictions. You will have to set upper limits and minimum limits for your Postgres containers. And if you use a suboptimal value, it is likely that at some point the Linux out-of-memory killer will start killing your Postgres processes because more memory is needed. Similarly, if there is a memory pressure on a server in your cluster, Kubernetes might decide to evict your Postgres container from that node to make room for others. So you really have to find the optimum value. Unfortunately, finding the optimum value usually requires some trial and error, so you will face some switchovers. And the Kubernetes issues. According to Cloud Native Computing Foundation, Kubernetes is the second largest project on the planet after Linux itself. So it has a very large code base. There are a lot of components interacting with each other. And your Postgres is tightly coupled with this infrastructure. It is inevitable that there will be some bugs in the software itself. Or you will face some user errors. Your Kubernetes administrators will do something wrong. Don't blame them. It is inevitable. And since your Postgres is tightly coupled with Kubernetes, any issues in the Kubernetes product itself will eventually affect your availability. And that's one of the reasons to stay away from Kubernetes. If you decide to use Postgres on Kubernetes, there are some challenges for DBAs. It is that there is really a lot to learn about the containers and Kubernetes concept itself. It's not like learning about a new database tool. It's a completely different world out there. And unfortunately, the learning curve is steep. As DBAs, we already have a tight schedule. Actually, most of the time, we are in a firefighting mode. We have some problems in our systems that we are trying to fix, or we have open tickets from other teams. So it might not be easy for you to spare time to learn all these concepts, and that's a disadvantage. Before ending the presentation, I will talk about the future of Kubernetes on Postgres on Kubernetes. These are my insights. These predictions are based on my insights on the technology, and they contain some spoiler. Okay, that's the thing. By time, we will all probably have to migrate our Postgres onto Kubernetes. So why do I say that? Well, because there are developments that are out of our control as the DBAs. So we have seen the timeline. It will be fair to say that the paradigm in virtualization technologies has shifted from virtual machines to containers. And containers is just not a hype technology. We have been using it for a long time, and it is here to stay. So the databases simply cannot stay out of this paradigm. So they will have to interact somewhere. And the second reason is that the communities and vendors are constantly adding new features to those operator projects. And these projects are getting better and better every day. So it will be really difficult to provide arguments against their usage, because these guys know what they are doing. In the first stages of projects, they had flaws, but they are fixing it. So we will probably all have to use one of the projects. And this is the last one, and I think it's the most important one. Your clients or your company might want to get rid of the virtual servers altogether, because those virtual servers have some license cost and maintenance cost. For example, the VMware was acquired by the Broadcom, and one of the first things that Broadcom did was to change their license policies. Now, if you want to use VMware, you have to buy at least 72 CPUs license. It was previously 16, so they increased the limit resource license usage from 16 to 17. That's a crazy increase. So the companies started thinking on ways to get rid of the virtual servers. One method was to move to an open source hypervisor, and the other method is to migrate as much as possible to Kubernetes. So in the future, we might not even be able to find a virtual machine to run our Postgres on. And this is totally out of our control. Because, okay, we are, as a DBAs, we are hardworking and we are smart, but we are not the only players in the IT organizations. There are some developments out of our control. Okay, thank you for your time and patience. That's all I wanted to say. It seems we have some little time left. If you have a quick question, I can take. Otherwise, we can go to have lunch and have some to eat. Yes, please. Well, I hear this question a lot. People usually think that when you run Kubernetes, it will have some performance disadvantages. But actually, it's the same process. It's the same Postgres, you know. The operators is just managing the environment. The Kubernetes is just managing your environment. But the Postgres process is the exact same process. It's the exact same process. So it's not a customized version of Postgres. So I can say that you will face some switchovers, which we have already mentioned. But for performance, it's the same. No difference than running on a virtual machine. But if we want to enter into details, there are some technical details. Let me mention. We have limits on the CPU. And on Linux, we have what we call completely fair scheduler. This is how the Linux decides how much time you can spend on the CPU. So you will have to put a CPU limit on the Postgres container itself. And if you don't use if you use a suboptimal value, it will be possible, it is likely that that scheduler will throttle your Postgres container, and it will degrade your performance. So you have to find the optimum values. Normally, on a regular conventional virtual servers, you have your dedicated database virtual machines. So nobody is going to throttle your CPU or processes. But in Kubernetes, it is possible that this scheduler will throttle your CPU. So there will be some degradation. But they can overcome you if you use optimum values. So I think that's but performance is not a way to is not an excuse to stay away from Kubernetes. Those challenges can be overcome. Just please.
Question that I had was, let's say that there's a use case where you want to run probably a database of, I don't know, 100 plus terabytes. So is there any operator that would give this feature of plugging in a storage appliance instead of the regular storage engines like Cinder, OpenEBS? If I don't want to use them, I want to use a storage appliance. So can you think of any
storage appliance?
Yeah.
Okay. This operator runs on Kubernetes, and on Kubernetes, actually this operator doesn't care about where you store your data. So it's totally transparent to that. But your Kubernetes administrators have to configure your environment to use that storage operators for yourself. So it is something that your Kubernetes administrator should handle. It is not related with the operator itself.
Hi, thank you for the talk. I heard that rapid increase of storage or something like auto storage management is difficult on Kubernetes. I'm not using Kubernetes, so just wanted to ask you, is it possible?
Well, when you set up your cluster, you set in the YAML file, you set your size. For example, in this example, we said that we wanted a cluster with 20 gigabytes in size. If you feel it, you have to extend it. But again, when extending, all you have to do is change the YAML file. So you will, for example, change from 20 gigabyte to 40 gigabyte. Then the operator will connect to your Kubernetes and extend your disk automatically. So it's actually more easier than you think. But it will not happen automatically. You have to monitor your disk usage using Prometheus or another monitoring tool. You have to define your alerts. For example, when the threshold comes to 18%, you have to manually change the YAML file. But if you want, you can extend operator and to do it automatically, but it must be a feature. It's not currently supported.
Thank you.
If I may, I want to add something to your question. So we have been using Kubernetes and running Postgres many years.
Which operator are you using?
Zalando also.
Okay, great.
And our project started, like many Kubernetes projects, I guess, from the DevOps side of view, from the DevOps context. So meaning that we want to do CI/CD, so continuous development and deployment of software. And for many DevOps guys, databases is a little bit unknown and unfamiliar, of course, and they are not aware of storage either, of course. So we also hit there a stone that they provided storage which was not extensible. So due to driver versions, if I well remember, and so on, and then you are indeed blocked. So you have to, or copy it over or backup restore to a new volume or whatever, or just play around with your reader follower. But that's not the situation you want to arrive in a production environment, of course. So it's a good question. You have to pay attention to the typical things as DBA, which DevOps peoples are not aware of course. And another critical element might be that if you run Kubernetes and Postgres on Kubernetes, the guys will specify or spec your Kubernetes nodes on CPU level to rather tiny specs. 8 CPUs is something, 16 might be common scene, but you might have a database which needs much more than that. So you should be aware that, like on every hypervisor, you cannot break out your single writer node to more than one node inside your spec of your hypervisor. So should be aware of that. So you should inform the Kubernetes guys which set up the cluster, hey, I need a node, at least one node of 32 CPUs or something like that. But if people start with Kubernetes, just to round up, those people will live in a microservice context, and every service, every process is tiny, and they will scale like the cattle and the cow and how they name it. So the many processes and many pods and so on. But for Postgres, you have one leader. So you should be aware of that, I think.
Sorry, you had a question?
No.
Okay.
I wanted to add something to that.
One thing that, about your concern about performance degradation, if Kubernetes throttles your CPU because you are overusing your limit, it will report that. So we normally have alerts in place. So if somehow the Kubernetes throttles our containers, we are notified. So we try to tweak the limits to find optimum values for that. So yes, the Kubernetes will actually throttle your CPU or memory usage, but it will report it so you can tweak it. Any other questions, concerns? Yes, please.
In your first slides, you say you do horizontal scaling.
Yeah.
Then you give an example where you say, okay, I'm spinning up these 3 HRDB sitting side by side in 3 pods.
Yeah.
But they're independent, right? It's not like if you update on one, then
Just let me open the slides.
I should be throwing this one instead of walking around, but I think everybody heard you.
So this is what a regular cluster would look like. We have 3 physical servers in our Kubernetes cluster. And I said that I wanted a Patroni cluster with 3 members. So this is a 1 member. This is the other member, and we have 3 members, and they are evenly distributed on the cluster. That's what I mean with load balancing. And
yeah, but I'm not familiar with the Patroni concept, but I was just wondering if my application connects to server A, and I do all my work and make all the changes, and then the day after I connect to server B, I will not have those changes.
Okay, you are talking about the load balancing and the master, the leader node and the follower node.
I was just wondering how does it scale?
In this example, this is a Patroni cluster. Only 1 member is the leader node, and the others are the follower nodes. So you can use the follower nodes for read-only access, but the leader node for the read and write requests. In Kubernetes, we have what we call the services, And this operator creates a service, and when you connect to that service, it directs your connection to the leader node. So this is implemented using Kubernetes features. You don't have to worry about, you don't have to use an external load balancer like HA proxy. On Kubernetes, you don't need an HA proxy. The Kubernetes will automatically do that for you. I think that was your question.
Yeah, okay. Thank you.
Okay, no questions, I think. Yeah, sure.
Thank you. So the question is, what if I want to build a cluster, a Postgres cluster, across different regions? Because Kubernetes cannot span across different regions. It can span across different AZs, I guess.
Yeah.
What if my infra doesn't allow me to create AZs, or I don't have AZs at all, I just have regions? So what kind of operator or solution could help in this case?
Okay, this was the diagram of a disaster recovery solution. Here, okay, you have the primary Kubernetes cluster in one region. This is your master cluster. And on the right, you would have a secondary cluster, and it would be in a disaster recovery site for you. So they can be totally on different geographic locations. And how they interact is using this S3 buckets. So you place the backup files in an S3 bucket, and the disaster recovery site automatically fetches them and replaces them. However, if you are asking if I can add a new server, for example, I have C and D in another site, it is possible, but it would not be a typical Kubernetes cluster configuration. Your Kubernetes administrator will probably not like the idea, because in a cluster, you want the nodes to have more or less equal processing power and latencies, because Kubernetes will distribute the containers evenly. They should be able to respond more or less in the same time. If you place it in a different geographic site, that node will perform poorly than the others. So it's not something you would like in a cluster.
Okay. I mean, my concern, at least the environment that I'm looking at right now, is if my entire data center is down, then there's a possibility that my new new to-be primary could potentially have a data loss, because it's the wall logs are going on to S3 and I've got to copy from them. So
yes. You won't have any, actually we do this. Here in this example, I used a simple S3 bucket, but most of the time, those S3 buckets will also have some replication features implemented on itself. So you can actually replicate this S3 bucket to another region if you want. So you will have 2 copies of the wall files, and you can replay them and sync your standby cluster with that.
I mean, there's always a possibility of that window where, because you're not streaming wall logs unlike a regular Postgres cluster.
Well, if you want, you can. That's actually the standby Patroni cluster we know. It's the same Patroni. Yeah. It is possible to configure that Patroni to stream from the primary instead of the bucket. It's not a requirement, but if you want it to stream, you have to set the password of the Postgres user in that secondary cluster. So it's a manual work. If you want it to be 100% automated, we use the S3 bucket choose. It's 100% automated. However, it's also possible to stream that, but you have to manually set the password.
Thank you.
And you can even configure it as a sync replication. It is supported. So it's the same pattern we know.
Yeah.
No worries, Kubernetes doesn't intervene your Postgres. It's the same regular Postgres you know, so you don't have to fear that.
Thank you.
Okay, thank you very
Emre,
much
for this very interesting talk.